Today we are going to look at congruent triangles. Remember that congruent means same size and shape. Also remember that our symbol for congruence is the equal sign with the squiggly line over top. When we're talking about congruent triangles and congruent polygons in general, congruent angles or corresponding angles have to be in the same position. And corresponding sides also need to be in the same position. Now our corresponding angles and our corresponding sides, there have to be the same number of them, and they are going to be congruent. They have to have the same measure. So our first one here, we have a set of congruent triangles. We have triangle ABC is congruent to triangle DEF. This right here is the congruent statement. Now you can use your picture or you can use the congruent statement to name your corresponding angles and your corresponding sides. When you're using the picture, you look at the number of arc marks for angles and the number of tick marks for sides. That means that for our corresponding congruent angles, angle A is congruent to angle D because they both have one set of arc marks. We also know that angle B is congruent to angle E because they have two sets of arc marks. And we know that angle C is congruent to angle F because they have three sets of arc marks. Then if you look at your sides, you want the ones that have one tick mark, and then you need to name by your corners. So segment AB is congruent to segment DF. And yes, order matters on this one because angle A was congruent to angle D and angle B was congruent to angle E. Then you have segment BC is congruent to segment EF. Again, two tick marks, and then look at which angles were congruent. So segment BC congruent to segment EF. And lastly, we have segment AC being congruent to segment DF. This one has three tick marks, and then look at your angles to know which ones are congruent. Again, order matters. Then we are looking at polygons. Polygons, again, their congruent statement is right here. You name your two figures, and the order of how those figures are named tells you what parts are congruent to each other. Now on this one, I'm not going to use the figure because we have too many things that are congruent. I'm going to use the names. Angle P is congruent to angle W. Those are both the first letters in the names. Angle Q is congruent to angle X. Those are both the second letters in the names. Angle R is congruent to angle Y. Those are both the third letters in the names. And angle S is congruent to angle Z because those are both the fourth letters in the names. Then we need to look at the sides. And sides, remember, have 2 points, the end points. Our first side would be segment PQ. So those are the first two letters of the first figure. Then it would be congruent to segment WX because those are the first two letters in the second figure. Go on to your next side. That means segment QR is congruent to segment XW because those are the second and third letters in our names. Then we have segment RS being congruent to segment YZ because those are the third and fourth letters in our names. And we need one more side because this is a four-sided shape, it's a four-sided polygon. It's a rectangle. That means we need our first and last letters. So segment PS is congruent to segment WZ. Again, the order of your vertices in your congruent statement tells you what parts are congruent. Our next example, we are given that triangle RST is congruent to triangle LMN. Identify our congruent corresponding parts. First off, we're looking at RS. R and S were the first two letters, so we want the first two letters in the second triangle's name. So this would be segment LM. And that is an L, not an angle symbol. Next up, we're looking at angle T. T is the last letter in the first triangle, so we want the last letter in the second triangle. We need angle N. Now, when you type these in, you need to tell me segment LM and angle N. You need to tell me the name. If all you type in is letters, you're telling me points. We are not naming points. We are naming segments, and we are naming angles. Next up, we are looking at segment NM. And NM were the last two letters in the second triangle, so we want the last two letters in the first triangle. So segment NM is congruent to segment ST. Our next example, we have that triangle EFH is congruent to triangle GFH. This means that angle E and angle G are congruent, so I'm going to go ahead and mark that. We already know that angle E is 21.6, so that means I can put it over here for angle G as well. Then we know that angle EFH and angle GFH, so these top two angles, are congruent. And we know that angle EHF and angle GHF are also congruent. And since we know that angle GHF is a right angle, meaning that it is 90 degrees, we know that this other side is also 90 degrees. So now we can solve for x, because we know 6x minus 12 equals 90. We are going to add 12 to both sides. That gives us 6x equals 102. Then we're going to divide by 6. And x equals 14. And we're finished with that part because we were just looking for x. Now we are looking for angle GFH. So we are looking for this angle. So we are in a larger triangle here. We're in triangle GFH. And we already know two angles in that triangle. How do we find the missing angle in the triangle? It becomes x, and then we add all of those together. So x plus 21.6 plus 90 equals 180. Then we need to combine our like terms. So we get x plus 111.6 equals 180. Subtract 111.6 from both sides. And we get 68.4 for x, which is the measure of angle GFH. Next up, we're looking for the measure of angle A. Now, angle A has an x in it. It's not the only thing that has an x in it. We have 5x minus 15 that has an x in it. And we actually know something about that angle. We know that it is 90 degrees. The reason we know it is 90 degrees is that this bottom segment is a line. And remember that when two angles create a line, they are supplementary. And we know this angle is 90, so the other side is also 90. That means that 5x plus 15 equals 90. We are going to subtract 15 from both sides. That gives us 5x equals 75. Then we're going to divide by 5. And x equals 15. Now we are not finished because that just is x, and we wanted to find the measure of angle A. Now, the measure of angle A in our picture was 2x plus 16. We need to substitute that x, that 15, in for x. So 2 times 15 plus 6 will get us the measure of angle A. 2 times 15 is 30, and 30 plus 6 is 36. So the measure of angle A is 36 degrees. Next up, we have a proof. Now, the first thing I want you to do every time you have a proof is circle the given information. Anything that is given to you, so all of this, you can write given next to in your proof. Now, what says prove by it, you cannot write given next to it. Only what says given. So we need to look for angle P and angle M are right angles and write given to it. That's our first one. Write given. Then we need to find R is the midpoint of segment PM. So number 5. We'll write given next to it. Then we need to find segment PQ is congruent to segment MN. We don't have that. We need segment QR is congruent to NR. We don't have that. But over here on the right, we have something that says given. So we're going to put down segment PQ is congruent to segment MN. And segment QR is congruent to segment NR. And then for the last step on all of your proofs today, you need to write down definition of congruent triangles. And that will be what you have every time. So, I already filled in half of my proof and didn't work through the other things. You can get half of your points by filling in your given information and putting down your last step as definition of congruent triangles. Now, we're going to go back and look at what we have. The first step says that angle P and angle M are right angles. Now, what do we know about right angles? We know that they're 90 degrees. So that means that angle P is 90 degrees and angle M is 90 degrees. Now, if both of these angles equal 90 degrees, that means that we know that they are congruent. We know that angle P is congruent to angle M. The reason we know this is the right angles theorem. Next up, we're looking for vertical angles. Now, do you remember what vertical angles are? Vertical angles, remember, are formed by two intersecting lines, and they're across from each other. So we need two angles in our triangles that look like that. Don't just tell me angle R. Angle R names a lot of angles. We have angle QRP being congruent to angle NRM. So this set of angles here. So right now we know we have right angles, and we know our vertical angles are also congruent. So we have two sets of angles in our two triangles being congruent. Our next justification says third angles theorem. Now, if you don't remember what third angles theorem is, go back to day 1 of this unit and find where we talked about third angles theorem. It says that when you have two sets of congruent angles between your two triangles, which we do, that last set of angles, that third set of angles, is congruent. So angle Q is congruent to angle N because of the third angles theorem. Then we were told R is the midpoint of segment PM. Now, when you think of midpoint, we have our segment, and R is the midpoint. So if R is the midpoint, that means it's in the middle. It means that the two sides are the same. They are congruent. That segment PR is congruent to segment MR. Oh, that's what our next one says. So we know that because of the definition of midpoint. So again, on proofs, get your given information filled in first. Your last step, write down definition of congruent triangles. That gives you half of the points for your proof. Do that first, then fill in everything else. Okay, then our last one. Again, circle your given information, and you can write down given next to it. Remember, proving, you cannot write down given next to it. There's something else we write down next to what we want to prove. So first off, we want to find segment JK is perpendicular to segment KL. Remember that upside down T means perpendicular. And that's in our first one. And it has segment ML is perpendicular to KL. So we've got that as well. We need to write down given next to it. Then we want to find angle KLJ is congruent to angle LKM. That is number 4. And then we want to find segment JK is congruent to segment ML. That's down here on number 6, and it also has segment JL being congruent to segment MK, which we have as well. So we write down given next to it. Now, what did I say to write down for your last step? Definition of congruent triangles. So we have half of our proof filled in. Now, let's go back up and figure out the rest of it. Our first one says segment JK is perpendicular to segment KL, and segment ML is congruent to segment KL. Now, what do we know about segments that are perpendicular to each other and the angles they make? They make right angles. That's what we can say in this next one. It is because of the definition of perpendicular. We know that those two angles are right angles. Now, we know they're both 90 degrees. They are both right angles. So we use what we talked about in the last problem, that when you have two right angles, they're congruent to each other because of the right angles theorem. So angle JKL is congruent to angle MLK. So we have our right angles here in the corner, and we know that angle KLJ is congruent to angle LKM. Now, that was given to us. So that is this angle and this angle. So we have two sets of angles in our two triangles. If you aren't sure what I'm talking about because you don't see your two triangles, we have triangle JKL, that looks like this, and we have triangle MLK, that looks like this. So we have two sets of angles that are congruent. How can we tell that our last set of angles are congruent? We used it in the last example. Yep, third angles theorem. And then we're finished with that proof.